My name is Chris Phillips. I'm the owner at Greening Homes. I've been operating since 2007 with the mandate here in Toronto to minimize the environmental impact of our work. My background is in building science. I have a master's in building science from this university, and have also a background in sustainable building design, and entered into this field really through Chris Magwood and his work at Fleming College way back in the day.
Okay, great. And I am Terrell Wong when I'm not doing the treasury stuff at Boots on the Ground. I run an architectural firm called Stone's Throw Design. We do, as best we can, low energy, high efficiency residential projects. And let's just keep going because that's the boring stuff. All right. You got it to work, so.
It's working. This part's working.
Yeah.
All right. So should we set up the project?
Yeah, set up the project. So the clients live in a small bungalow, or lived in a small bungalow here on the left. And it's at the bottom of a very large denuded ravine, sitting in water.
There is literally a river that goes underneath it.
Absolutely.
Yes.
And so the denuded ravine is full of weeds, and the client worked very hard with the TRCA to build a edible forest up that entire slope. When you're at the top of the house, you're 4 stories high, maybe even higher when you're at the top of the ravine. So a challenging site, and the client decided his whole world is dealing with climate change and anxiety around climate change as a psychologist, and he wanted to do what he was telling his clients to do. So it's his family and his wife's family, I believe, yeah. And they decided to put a multi-generational family. And one of the passions that I've had for years is looking at the existing building stock and thinking, how much of that existing building stock can we reuse and then rethink about how we're living in houses in Toronto?
Well, I mean, and the best part of this was a client who not only wanted to look at energy efficiency, but wanted to really reduce the environmental impact of what he was doing as much as possible, and that was in relation to all the materials that we used. It was an incredible opportunity to be listened to, and you'd make a suggestion, it's like, okay, I will do that, and I am willing to go without. Which is
great.
Pretty incredible.
It is. And we started with it. So the pictures here are just showing iteration after iteration, because it's way cheaper to design it than it is to build it and then change your mind. I remind my clients of that on a regular basis, and sometimes it doesn't work. So luckily this time it did. We did a lot of work up front, bring the builder in early. They are a resource. Anyone asks an architect how much something costs, they're lying to you. They don't buy this stuff. And the price changes so quickly, it's just not a topic that you should be bringing up. So we bring in Greening Homes early so that iteration and that knowledge can help get us to the point where the client isn't killing us and they're not going broke, and we can finish the buildings.
Well, the next slide shows this really awesome stairwell that unfortunately had to get nixed.
Yes. So, a client comes in, they have grand dreams. So they wanted a greenhouse and a covered balcony, and they needed extra space, and they wanted everybody to live da-da-da-da-da-da-da. So we designed it, and we priced it. Tell them how much that little sliver cost.
It was about $300,000 or around that, because we had to create a whole new foundation with really nice triple glazed windows, large triple glazed windows going up 3 floors, and really fancy stairwell. And that was quickly, we decided, okay, we're going to work within the existing foundation.
Right. Yeah. So the original design had everything they wanted, but it was too expensive. And so then we went, okay, let's go back to the original foundation. So you'll see here, I don't know if my little thing shows, that everything fit, and the tiniest OBC stair ever. That's the smallest it can be to make this project work.
Which, when it came to eventually bringing up the windows 3 floors, we realized we couldn't do that upstairs, so we just had to cut holes in the floor and hoist them up.
So one of the things that we do together as well is look at the air barrier, the vapor barrier, and go through the crayon drawings that you need to explain how you're going to do it or how you think you're going to do it. So in this case, we did make some changes due to water on the site. Chris, why don't you walk them through
Sure.
the main thought?
The goal here, I guess, from an insulation perspective, was to try to be as cellulose-based as possible, so interior and exterior. There's a lot that we don't include in this presentation, but this is sitting in water, so at the demolition stage, everything was mold-ridden. So we had to, we went with rock wool in the below grade, which is often what we would do anyway, but we were worried about moisture and just the walls sitting in water. And the air barrier was made continuous by working from the inside. We had a wet applied Stowe Gold on the masonry walls, and then wrapped that air barrier up to the exterior for the new framed section.
Yeah, and the idea being that the overlap between the interior work and the exterior work deals with the air barrier issues of a not exactly always continuous.
That's right. And if I can say, we
did manage to get to the outside on this one due to the situation on the site, because you never know what you're going to find, and a river is very wet. So in this case, we ended up waterproofing from both the inside and the outside, and it is now a boat.
Right. And I can say we're at 0.94 changes per hour, but we have some issues with our door insulation and gaskets, so we should be well below 0.6 by the time this is.
And we know who the windows are, so we can talk to them.
It wasn't Vetta's fault.
No, it wasn't. Actually, the great service is what we love about them, so that's good. So there you go. Instead of digging down, which we couldn't do anyway, but one of the things that I've been thinking about with reusing existing brick structures is why not build up? Scoop out all the wood and build up. So we added 3 or 4 levels of block and put the new first floor at a different height. So now the basement has the full, is 8 or 9 feet in the basement, I believe.
All right.
Okay. So.
It was very quick, as you can see.
Yeah, it happened in no time.
Site complications, urban build like this. This one had a few. We mentioned the river underneath it. You can see the lot line of the neighbor, literally building on the lot line. And this particular neighbor wasn't particularly excited about the build. So we had lots of calls from the city and that type of thing. There was no parking outside, so you can imagine when we had everything delivered, including this is the Gutex being delivered, it would take up the entire street.
Yeah, we wrapped the entire building in how many inches? 6 inches?
Oh, 6 inches I think it was
6 inches
for the exterior. And we had a school, so we had to work within the parameters of the school opening and closing. There was a TPZ at the front, so we weren't able to keep, we didn't have a landing zone, so we had to actually crane everything over. And then in the middle of the project, they decided to change the sewer line right in front of the building. It was challenging, and that's basically the homes around it.
Okay. So one of the most important things for both of us has been to try and choose the right materials for the project. The client was in on it, and we went through the beam system and looked at, and okay, honestly, as you said, we did it afterwards because we've been working in these materials for a while.
We made the specifications and then checked it afterwards.
Yeah, we did. And, so, and this one's showing up a little bit dark on that. I don't know why. Anyway, looking at all the different things that you can use from XPS, which is really high on the carbon scale, and we ended up using wood fiber board, which actually lets us sequester carbon, which is really important to us, and doing these tallies. And Chris and Greening Homes took the time to actually do the math.
Well, Carolyn Moss, is she
Carolyn Moss,
here?
yes.
We brought her on board to do that for us. But,
thank you, because I'm not doing it. So here's another material that you like to talk about, so why don't you do that?
It's one of the biggest things that you can do, as many of you would know in this room, is if you're pouring concrete, if you're going to use concrete, and to have high SCM, supplementary cementitious material concrete. It's about 40% slag. And it's one of the biggest impacts you can make in terms of carbon. Okay.
We gotta go quick. So the Gutex is on the outside, and because of how it comes, sometimes it comes in the 2 inches, 4 inches, 1 inch.
And in this case.
And in this case, every inch.
Every inch, because we couldn't get what we wanted, so we ended up having to buy it in multiple, different thicknesses, and of course that was fun to install multiple layers instead of one in this challenging location.
Yes, and this shows Greening Homes' very secret way of doing the air sealing for their windows and cantilevering them out into the insulation. but we won't go into the details. Oh, this one's fun.
This is cool. This is so we did for cellulose space. It makes quite a mess, but we used damp pack cellulose in our wall cavities, and there's a whole reason for that. If you put on your Intello first and then you put in the blown cellulose, and you end up with pillowing, it's hard for the drywall stage. This was an opportunity to, you blow it in and then shave it off, and it looks like a perfect monolithic insulation when you're done. It is very, very messy, and also didn't stick to the stow gold, so that was another challenge.
Okay, this talks about our Shoshugibon exterior. I worked very hard to say that properly. So we've decided on this one to use the charred cedar product around the building.
So local wood, locally produced, charred wood windows from Veta, triple glazed.
Yeah, triple glazed windows are the best. This is another one just showing you better pictures of that Shoshugibon put on. There's some care that has to be taken when you're on site for it not to get, chipped or scratched.
Yeah. This is a bit of, do you want to?
Yeah, sure. So one of the things that the client was very good at was being able to get dead stock items. So I find when clients are really interested in doing environmental things and then they find out it costs more to use a used door, they don't. Or it takes their time to go dumpster diving to find the dead stock flooring or whatever to make it worthwhile, that they don't. But these clients found, how many different floor types did they use?
Every room has a different floor, and they went, which is maybe 7 or 8 of one thing. What was amazing is that they went to Nadura, which is one of our floor suppliers, and they bought all sorts of flooring for 100 square feet was left, and they would put that into a room, but it all perfectly kind of blends together, and the cork flooring was actually taken from a couple of rooms were from cork flooring from someone else's home that they just lifted up and then we reinstalled it. It was pretty awesome, actually. Looks great. Let's see.
So here's some of the details for air continuity in the basement. This is part of the bathtub detail that goes right underneath the slab.
Technique. So you've got that continuity of the below grade, and
then it's taped to the stow gold that can be done above grade to create that continuous barrier.
Yeah, using rock wool here.
And then we use the Mento 1000 on the outside, showing our great taping details.
You have to show the great taping details.
You have to show the great taping details, okay. Yes, absolutely. And then this is your favorite part, so tell me, I want to hear all the good stuff you think about my detail.
What I love is we always have sometimes challenges going with cathedral roofs that don't use spray foam, and sometimes it can be a challenge at the city. And what we did here was have a vented cathedral ceiling which uses cellulose insulation, so we're able to stay away from the foam.
Yeah, so the sheathing is actually in this one. I think it's on top of the ventilation area. So it goes plywood, so metal roof, plywood, required by the city, ventilation. But what I decided to use it for is to create a very thin roof that I can make any shape I wanted to. So we had some fun with that for overhangs. There's a cantilevered balcony on the 3rd floor where they can sleep in the summertime, so you can see some of the deep overhangs you can get when it's just holding itself up. So that is my ventilation strategy to beat the City of Toronto's code. Showing some of the lovely Intello being taped on the inside over top of our wet, no longer wet cellulose. And then you want to talk about the potable water?
There's so much we can't talk about here because we don't have the time. But one of the highlights was that this has a potable rainwater harvesting system that provides up to 33% of the entire household needs for the year. And that was an interesting, that was wonderful to be involved in. We know that there can be issues with rainwater and leaching, leachates from solder and from from the various lines. You don't want heavy metals getting into your water. So this was fun for me because I had an opportunity to like really nerd out about stuff and
Yeah.
do the, make sure that all the connections, because the connections matter from, we had to choose the right type of roofing material. Everything had to allow it to be potable. And this was like, when do you get a chance to do this in the city? It's awesome.
Okay. Net zero is well within reach. So the clients will be able to make net zero if they add a few more solar panels, but that will be done in the economic future of their dreams. So I think we did very well in terms of getting things down and being able to reuse that building.
And we have like 6 people living there and 2 HVAC systems, and I mean this is actually a good comparison of the embodied carbon in the home. Do you want me to go for this one?
Well, I'll start with it. I now understand it, so I'm going to go through it. So the original home is what was there already. The house exists, and we kept everything in terms of masonry. So everything else got taken out. So 17,000. I'm just going to round down. And then the low carbon DER is our renovation, and that's everything we added to it to build a 3-story structure. So we only added 13,500 kilograms.
And you can see the net kind of carbon storage and all of that cellulose that we used in the building.
So that helps us bring that number down. And then a typical deep energy retrofit is going to use around 33,000 if you're just using standard details, you're not going crazy. And then a new build, if we had thrown out that foundation and done it all again, almost 75,000 kilograms of CO2. So we feel we did the right thing.
So, and what does that mean? Oh, no, yeah, not that. That's the next slide.
What? Do you want me to go back?
No. We'll,
what does that mean?
We'll put that what that means in terms of
definitely.
weight in a minute. But
how did you get those calculations?
We have.
How did you get those calculations?
Well, you're going to ask me the right names and the right people's names.
Builders for Climate Action.
There you go.
And the Beam tool, Chris Magwood
Thank you. You're very
Jacob
helpful.
Husen and that group. We're almost there.
We're almost there. 2 minutes. So the orange line. Explain the orange line.
Okay, so just very, very quickly, we can explain this in more detail. But this is our renovation over here. This represents the amount of embodied or carbon emissions from the materials that were from the actual build, and that flat line is the emissions for the project. That red line that goes up, that's it starts where the original building started.
If we've done nothing.
If we've done nothing, and I mean all the other lines are representative of what that would look like if you built it in a different way, or if you built it with gas versus electric. A typical reno with gas, that's that line, that kind of olive line. You can see how much more embodied carbon we're dealing with, and that the emissions continue up. And if you've just gone with a typical reno and electric, you can see the delta there as well.
So this is why we don't want to build new necessarily. Think about it. 99% of the buildings are already here. We could do whatever we want to with that last little new one every year, and we'd have no effect. So it's the existing buildings that make the biggest effect on our carbon footprint going forward because they're already here. So really the most sustainable thing that you can do isn't necessarily nothing. We've proved here that it is a green, deep energy retrofit that really thinks hard on the low carbon materials and using cellulose and sequestering. It's just, the numbers prove it.
And it's built within the range of what you would expect for a renovation project of this time, like almost 61,000 kilograms of embodied carbon emissions. That's
what it equals.
20 African elephants, 43 Honda Civics. That's how much you're able to save in this project. And this is some finished stuff.
These are our pretty pictures, so we really are finished. We just thought you should see that it did get finished. And it is, it's a little livable. It's livable. I could live there. Yeah. It's
got, so there's so many things we could talk about. The plaster party, the client's ready to move in with primed walls, and so we can't let that happen. If you buy the natural plaster, we're going to hold a party, so we brought in a band and food and drinks that progressed through the day in a late August, hot, sweaty day, and we finished. 23 of my closest friends from the natural building world.
And a band.
built this up. And a band. Yes, the band was pretty awesome. We have so much we could show here, but it was pretty awesome project to be part of.
Thank you very much.